Hi everyone. So now we are in the equation of straight line and we want to find what is the line perpendicular to a given vector in a 2D plane. Right, so let's say we have the vector r equals to r0 plus at. Then what we want to do is to find a vector that is perpendicular to this vector. And we shall write this as the vector n. So let's see how do we do this. So the first thing we need to do is to write the vector n equals to a constant which we write as p here, pi, plus q, which is another constant, j. So now when we want to find what is this component p and q, we just make use of the idea that the dot product between the two vectors n and r is going to be equals to 0. So that leads us to this equation, pxx minus x naught plus qy minus y naught. So when you write the dot product, you can easily see why or how you can get this expression. Now we just need to rearrange the equation so that you have y minus y naught over x minus x naught, and this is equals to minus p over q. So p is the I component and q is the j component in the vector n. So basically we just need to use this equation to find the vector n. So let's look at a more concrete example. So let's say we have a line from the origin to R, and this is given by 3, 5. So you will remember that this is actually means that you have a vector from origin 0, 0 to R, which is a point that is 3i plus 5j, right, like this. So now let's write the vector perpendicular to this R vector to be pi plus qj. So when you take the dot product, you will get q over p equals to minus 3 over 5. And this is basically the line that is perpendicular to R. So in order to see this, let's just rearrange the equation so that you have q equals to minus 3 over 5p. And now this might seem a little bit abstract, so let's just write this in terms of y and x. So you will remember that q is actually the j component, so this is like your y. P is the I component, so this is your x. So now you have actually a y equals to minus 3 over 5x. And minus 3 over 5 is basically the slope of your vector. So here I plot the vector for better illustration. So you will see that this is 3, 5, which is our vector r. And here this is 5 minus 3. So this is your n vector. So here you will see that the vector which is plotted from the origin, the vector n, which is given in the red line here, is actually perpendicular to the vector ZOR. Right, so that is how you find this perpendicular vector to a given vector that we already defined. Now to make things more challenging, right, what we can do is to find a vector going through a given point. So in this example, we have this r vector, that is this line, and now what we have done was to find a vector perpendicular to this OR vector, which is this vector n, given by 5i minus 3j. And now we want to find a vector that is perpendicular to R but going through this point R. And how do we do this? We need to remember that the vector can be written like this. You have R0 plus AT. R0 is basically the tail of the vector plus a vector A in a given direction times T. That is how many times the vector A. So in this case, when you want to find a vector that is perpendicular to R, right, perpendicular to R, and it is going to be in the same direction or same slope as the vector n. So in this case, you will see that R0 is actually the 0.35 here, And what is A? The A is basically the vector n that you have here. So because of that, we can write the new vector going through the point 3, 5 as R0, which is 3, 5, plus A, and A is basically my n now, and this is 5 minus 3t. So this is the vector. So one of the line that it falls on this vector n prime can be found if you take t equals to 1. When you take t equals to 1, you will have a point which is given by 3 plus 5, and this is equals to 8. So you have 8 and 5 minus 3, this is 2. So line point 82 is going to fall on this vector n prime. Right, so here I just give an example. The blue line is 3, 5. The yellow point here is basically the vector n, and now this point over here is the point 82. So here is the vector n, and this is the same vector but going through the point 35. So that is how you find the vector perpendicular to a given vector. And if you want to find a vector going through a given point, you just have to make use of this equation, r equals to r0 plus at. So that is all from this topic. Now the next topic we are going to go in is the equation of plane.